Welcome to Chapter 3, Section 3, probably Day 3 notes. For the next few problems, we need to solve each trig equation and write the general solutions in radian mode if it's x or degree mode if it's theta. We also need to find particular solutions within that domain, or whichever domain we're looking at. Either 0 to 2 pi or 0 to 360. Really quickly, little thing. Apparently, I did a little bit of research. The x being radians versus theta being degrees, or theta being radians versus x being degrees, that was sort of made up by one particular professor who wrote a very influential calculus textbook, where he generally used Forster, I believe was the textbook author. He generally used Greek letters for radian mode and Roman Latin alphabet for degree mode. But again, that was just one particular book that a lot of people read. There's no real rule about it, which is why we're able to swap back and forth, or why sometimes I might have said theta is radians or x is degrees or things like that. When it comes down to it, whatever they tell you is what we're supposed to do. So they said that x is radian mode. So if 4 times the sine of x times the cosine of x equals negative root 2, we need to figure out how to turn that into, we need to figure out how to solve this by turning this into a single sine or cosine equation. Well, negative root 2 is not necessarily one of my unit circle numbers, but maybe I could make it into negative root 2 over 2 if I divide. Also, 4 times the sine of x times the cosine of x doesn't really look like anything that I've seen before, but let's take a look at what rules we can create now. We can still divide by 2 there. So we have 2 times the sine of x times the cosine of x equals negative root 2 over 2. 2 times the sine of x times the cosine of x sounds a little bit like the sine of x times the cosine of x plus the sine of x, the cosine of x, another sine of x times the cosine of x. Sine of x times cosine of x, if you're multiplying, technically, the order doesn't matter. This is also why I made my little mistake here. Let's change the order to make it the cosine of x times the sine of x. And now we have sine, cosine, cosine, sine. So we're actually taking the sine of x is our first angle plus x is also our second angle. So we're actually looking at, and this is now a formula that we can create, the sine of 2x. And the sine of 2x equals negative root 2 over 2. So let's write that one down at the bottom here. New rule. The sine of 2x actually equals 2 times the sine of x times the cosine of x. That's a new rule. Keep that in your notes. Anyway, now we can take the sine inverse of both sides. And again, negative root 2 over 2 is on the unit circle, but it's on the unit circle in a couple of different places for a sine. So let's see what the principal value is in radian mode. Let's change our mode to radian for this one. And take the sine inverse of negative root 2 over 2. That doesn't really help me. What if I divide that by pi? That's negative pi over 4. So 2x equals, the sine inverse got me negative pi over 4 plus or minus 2 pi n, or pi minus what the calculator said, pi minus a negative pi over 4 plus or minus 2 pi n. That 2 is being held on through multiplication, so we can divide by 2 here after we simplify. So 2x is going to equal negative pi over 4 plus or minus 2 pi n. Pi minus negative pi over 4, that's really 4 pi over 4 minus a negative is plus, so we get 5 pi over 4 plus or minus 2 pi n. If we want to get rid of the times 2, we could divide everything by 2, or we can say that we're multiplying by 1/2, because that will distribute over both the 2 pi and the fractions. Multiplying by 1/2 is a little bit easier for me to deal with personally, but however you conceive of the idea of now we have negative pi over 8 plus or minus 1 pi n, and 5 pi over 8 plus or minus 1 pi n. That is our answer for part A, our general solution. And then we wanted the particular solutions between 0 and 2 pi. Well, if we're doing it, if we're looking at over 8, 2 pi is going to be something like 16 pi over 8. Negative pi over 8 plus pi. Here, let's make that actually negative 1/8 plus 1 and assume, so we get 0.875, which is not 2, plus another 1 would be 1.875. Okay, so what is 0.875 math 1 as a fraction? That would be 7/8. So negative pi over 8 plus pi, or 8 pi over 8, got me 7 pi over 8, plus another 8 pi over 8, so we can use that one, would be 15 pi over 8. 15 is still lower than 16, so we can use that. If we add any more, we're not going to get those. We're not going to get numbers within our values. 5 pi over 8 is a number that we can use as well, and if we add pi, again, that's like 8 pi over 8, and that gets us 13 pi over 8. 13 plus 8 is more than 16, so it looks like our 4 solutions are, for part B, the x values between 0 and 2 pi that we want in least to greatest are 5 pi over 8, 7 pi over 8, 13 pi over 8, and 15 pi over 8. Nice precise values. So we're going to do a little bit more of exploratory math here. We have the tangent, 2 times the tangent of x over 1 minus the tangent squared of x equals negative 1. 2 times the tangent of x sounds like, again, similarly to 2 sine x, cosine x was sine x, cosine x plus itself. We could get the tangent of x plus the other tangent of x. That was the wrong pen. Tangent squared of x sounds like the tangent of x times the tangent of x, and all that equals negative 1. Again, this looks like the formula for tangent of a plus b, except that your a and your b are both x. They're the same thing. So again, that's going to be the tangent of 2x. And we've created a new rule, again, like the sine of 2x equals 2 sine times cosine. New rule, the tangent of 2x, or 2a, or anything like that, equals 2 times the tangent of x over 1 minus the tangent squared of x. Anyway, let's go continue solving here. Take the tangent inverse. And again, that is x, so we're still in radian mode. Tangent inverse of -1 is that weird number again. Again, what I did to check what that was in radians was I divided by pi and then changed that into a fraction and then put my pi back at the top. So negative pi over 4 equals 2x. But again, we took an inverse, so negative pi over 4 plus or minus 1 pi n because it was a tangent inverse. Again, we'll divide everything by 2 or multiply by a half, depending on what's appropriate. And x equals negative pi over 8 plus or minus pi over 4n. Sorry, pi over 2. Pi over 2. I don't know where that 4 came from. So pi over 8, or negative pi over 8, not a positive number, not between 0 and 3 pi. Again, we can kind of take this in our calculator and see what these fractions would be without pi's. Negative 1 over 8. And then we'll add 1/2. And we'll turn that into a fraction. So 3/8 or 3 pi over 8 definitely works for us. If we keep adding like that, 7 pi over 8 is also less than 2. 11 pi over 8 is less than 2 pi. And 15 pi over 8 is probably the last number we can get, because after that, 19 divided by 8 is more than 2. I will see you in the next video.